What's up, everybody? Are you ready to learn about one of the most important topics in all of statistics? Hope you are, because in this video we're going to talk about when is a statistic significant. If you could understand this and totally comprehend what I'm about to teach you, then there's a lot of topics in statistics that are going to actually be really easy for you. So when is a statistic significant? Well, the best statistics in the world are significant ones. It's kind of why we like them so much. These significant statistics tell us about a population parameter. It tells us that it could be wrong, or maybe it's changed from something that we thought it was. But realistically, finding statistics that are deemed significant are really important. But before we could learn about how to know if a statistic is significant, we're going to first talk about how do we know if a shrimp is significant. Yeah, I'm talking about shrimp here, good old shrimp cocktail. When is this particular shrimp cocktail significant? Well, think about if an alien species came down to Earth and we gave that alien species a shrimp cocktail to eat, just one of them, and we said, hey, this is a significantly large shrimp cocktail and we want to use it to welcome you to the planet Earth. Now, how the heck would that alien know if that shrimp was significant or not? Well, it really wouldn't. Why? Because it has nothing to compare it to. For all it knows, that could be a small shrimp, a large shrimp, a really small, a really large, or just a normal shrimp cocktail. So the idea is that we can't really learn if a shrimp is significant until we compare it to all other shrimp. Then we can figure out if it's significant or not. So we look at a bunch of shrimp that we have seen many, many, many times, and we take our shrimp and we say, oh my gosh, look how big that is compared to those other shrimp. And then that gives us evidence that, yes, we do have a significant shrimp on our hands. And then after we show the alien all these other shrimp and how this shrimp is much, much bigger, then that alien can feel like, wow, you guys really welcomed me to Earth with this great big shrimp cocktail. But that's basically the idea, is we can't figure out if something's significant until we compare it to all others. So that's the same idea when it comes to statistics. So when is a statistic significant? Well, there are all different types of statistics out there. First off, we have the mean of a sample. How do you know if a mean of a sample is large or small or normal or, well, just plain old significant? Well, you have to compare it to all other sample means just like it. Same thing for proportions. How do I know if a sample proportion p hat is significant? Well, I can't until I compare it to all other sample proportions. What about standard deviation of a sample? Same thing. I won't know if it's significant until I compare it to all other standard deviations taken from that same population. Same thing for slope. I don't know if a slope is significant until I compare it to all other slopes. Same thing for median. Now just note, we don't have any fancy symbol for median, sorry. But again, if I have a median from a sample, I don't know if it's special or not until I compare it to all other medians. Same thing with range. It's, again, no fancy symbol for range. But again, you get the idea. A single sample statistic actually tells us nothing. We learn from it. We determine if it's significant once we compare it to all other sample statistics just like it. Just like the shrimp. All right. So here is the official definition that we're looking for, right? A sample statistic is deemed significant. That's that big word we're looking for. If the probability of it occurring is too low to have occurred by chance, on the assumption that a given population parameter is true. So think about that for a second. We can't actually officially, by definition, determine if a statistic is significant until we find the probability of it occurring. And if that probability is too low, that it could not have occurred by chance, then we could officially deem it as significant. So there's a lot going on there, but let's start off with that probability, right? We want to be able to find this probability. We need to find the probability of a sample statistic occurring. Okay, to do this, we need to look at all other sample statistics. And of course, we could do that with a sampling distribution. Now, I'm not going to talk about what a sampling distribution is in this video. I really hope you already know that. But if you need to, got a link right up here that could take you to many videos I have over sampling distributions. So to find the probability, we need to first figure out where our sample statistic falls in amongst the sampling distribution. Well, how the heck are we going to do that? Well, have no fear, the normal model is here. The normal model is literally like Superman swooping in to save the day, because the normal model is what's going to tell us if something is significant or not. So the normal model says, listen, values out here that are 2 or more standard deviations above the mean are very significant. And same thing with values down here, 2 or more standard deviations below the mean. Now, we could kind of debate as to where significance starts and stops, but for general purposes, we like to just say if you're on those tails, the upper tail or the lower tail of that normal model, you're going to be significant. So that's exactly what we're doing. So let's look at an example where we're talking about proportions. If I have a sample proportion and I want to know if it's significant, I have to first build the sampling distribution for sample proportions. Now, to build a sampling distribution, you need 3 things. First, you need the mean. That is literally the mean, mu, of all the p-hats. Because remember, just like the shrimp, we can't learn if a shrimp is significant until we compare it to all shrimp. So we need to find the mean of all possible sample proportions, and that should be the truth smack dab in the middle. Then we need to calculate the standard deviation, because we have to have this understanding that it's the world we live in. Samples are going to vary. Just like shrimp vary, just like people vary, even sample proportions are going to vary. So we need to calculate the standard deviation of the sampling distribution for sample proportions. Now, to do that, we have a pretty simple formula. We're going to take a square root of p times 1 minus p, all divided by the sample size n inside of that giant square root. That's going to tell us how far this 1, this 2, this 3 is from the mean. That 1 represents one of these standard deviations. Now, once we build this sampling distribution, and by the way, how do we know it's normal? Well, I'm not going to get into all the technicalities of it, but again, you need to watch more videos on sampling distribution. But the great thing is it's going to be normal as long as we meet some conditions, which you can learn later. But the idea here is, okay, now we have this sampling distribution with a mean, the center, that's the true proportion, and the standard deviation. Now we can say, okay, where does our sample fall in? If our sample falls right here, well, unfortunately, I'm sorry, that's not very significant. That's only a little bit, like literally the picture could see it. It's just a little bit above what's supposed to happen. That would be like giving a shrimp to the alien and saying, this is the biggest shrimp in the world, but then that alien looks at that shrimp compared to all other shrimp. It's like, dude, there's a lot of shrimp just like this shrimp. It's not really that special. It kind of fits right in the middle amongst all other shrimp. Don't lie to me. Well, the opposite would be if our sample fell like way up here. That's where we'd be like, whoa, that is pretty significant. That is really, really high. Or again, if we fell down here, that would be really, really low. That's where we start to see samples that are significant. They're really, really high when, guess what? They weren't supposed to be that high because this is where the center was. Now, we're not done yet because all we've found so far is where our sample statistic falls. We have to officially find the probability of it occurring or more extreme. So let's just say that our sample does fall right here. Well, we would then have to calculate the probability that any other sample is more extreme than the one we found, which I'm just going to leave blank right now because I'm not really giving any numbers here, but whatever it is, let's just say it was 33% or 10% or whatever the proportion ended up being. So the sample proportion would have a probability of occurring or more extreme of this. And notice how small that is, right? That's a very small probability. Whereas if I go back to the red one, if this is where our sample fell, then again, the probability of that sample occurring or more extreme would be all of this, which is quite large, which it means that it's likely because it has a high probability of occurring. If something has a high probability of occurring, it means it's likely to occur, which in turn means it's not significant. But if something has a very low probability of occurring, but it occurred, well, then it has, again, that would get deemed significant. Let's talk about this in terms of means as well. So once again, maybe we have a sample mean and we want to figure out if it's significant or not. Well, we have to build a model of what all other sample means look like, taken from the same population with the same sample size. Now, that sampling distribution is going to have 3 characteristics. It's going to have a mean of means, literally a mean of a bunch of X bars, and that should be the truth. The true mean should be in the center of that sampling distribution. Then we have a standard deviation that tells us, listen, right? We know one thing's pretty consistent in this world. Everything varies, so there is going to be some variation amongst our samples. So to find the standard deviation of the sampling distribution, we take S, that's the standard deviation. Well, actually, I take that back. I kind of have a mistake there. Should fix that. It actually should be sigma. Sigma is the standard deviation of the population divided by the square root of n. Now, I got to be honest, the reason why I had S there is because sometimes we might not know the standard deviation of the population, and in that case, we have to replace that with S, the standard deviation of our sample. But that's another topic. But again, this is simply us building the sampling distribution, and then, of course, the shape of it is normal. That's awesome. Now, then we can actually start to say, where is our sample at? If our sample fell right here, we'd be like, all right, that's low. It's on the low side. It's less than what's typical in the middle, but it's not that much low. But again, we can't just base it on how we see it. We have to actually find the probability. Going back to the definition of significant, we need that probability. So what we do is we look at that model and we say, okay, the probability of that sample occurring or more extreme. Now, since I'm already low, or more extreme would be even lower. And again, look at that probability. It's actually quite likely. It means that this sample was likely to occur, which means it's not special. Sorry to break it to you. If something's likely to occur, it's not special, it's not significant. But if we got a sample mean that fell way up here, well, that would be really low, and we could calculate the probability of that sample occurring, or again, why am I going lower? Because I was already low, so it would be even lower than that particular value. I'm just leaving that blank because I don't know, I'm just kind of speaking general here, but whatever that value is. But notice that that green area down there is a very low probability. That means that my sample should not have occurred, but guess what? It did, which is why I would deem it significant. So if we go back to the idea here, a sample statistic is deemed significant if the probability of it occurring is too low to have occurred by chance, on the assumption that a given population parameter is true. So the idea is to figure out if something's significant or not. We first have to figure out where my statistic falls amongst all other statistics, just like it, from the same population with the same sample size. Then we could find its location, and then we got to find the probability of that happening or more extreme. Now, that's actually what we call a p-value. So the probability that's going to help us determine if something is significant or not has a name. It's called a p-value. This is not just any generic probability like, hey, the probability you toss a coin and get ahead is 50%. I mean, that's a really cool probability, but a p-value is a very special probability. It is the probability of a sample statistic occurring or more extreme, given that a known population parameter is true. Once we find that p-value, that's what we could use to determine if something is significant or not. Anything that we deem really low is going to be called significant, otherwise not significant. Now, the next and final question is, what is too low? What is not too low? Well, that's kind of up to you. We actually call it your significance level. A lot of people use 1%, so anything under 1% is deemed significant. Other people might use 5%, then say anything under 5% would be significantly low. That'd be a low probability of occurring. But that's the general idea. And if you could wrap your head around this general idea of how we can determine if a sample statistic is significant or not, you're going to have a really easy time with statistics. But a lot goes into that. Got to make sure we understand sampling distributions and probability, and of course, the amazing, powerful, superhero normal model. All right, that's it for this video. Hopefully you understand this idea. If you don't, got lots more videos to watch in the future. Best of luck to you.